SpaceX has started testing the next generation of Starship. After nearly 6 months without a launch attempt, activity at Starbase has suddenly accelerated. A completely redesigned booster is now on the pad, powered by the new generation of Raptor engines and supported by an upgraded launch system built from the lessons of the previous flights. At the same time, NASA is pushing towards a possible April launch of Artemis II. China is moving ahead with its Mars sample return mission, and the commercial space industry continues expanding towards the next generation of space stations. My name is Connor, and welcome to another amazing episode of Spaceflight News. Let's begin with Artemis. NASA is now working towards an April 1st launch window for Artemis II, the mission that will send astronauts around the moon for the first time since the Apollo era. The mission will use the Space Launch System rocket and the Orion spacecraft to carry a crew of 4 on a 10-day lunar flyby mission, marking this the first crewed test of the Artemis architecture. But even as NASA prepares for that milestone, the long-term structure of the program is facing increasing scrutiny. A new report has criticized delays in the development of the Human Landing System, the spacecraft that will eventually place astronauts on the lunar surface. Both SpaceX and Blue Origin are developing competing landers, but the report warns that continued delays could push the timeline for the first crewed landing further into the future. NASA is already looking at future upgrades to the Space Launch System itself. The agency recently selected United Launch Alliance's Centaur upper stage technology as the basis for the new generation of upper stages for SLS, a change that could improve performance and simplify development for future Artemis missions. Taken together, these developments highlight a key tension in the Artemis program. NASA is preparing to fly the first crewed mission, but many of the systems required for sustained human lunar operations are still under development. Meanwhile, space exploration beyond the moon is also advancing. China's Tianwen-3 mission, the Mars sample return mission, has now officially moved into the spacecraft construction phase. The mission aims to launch later this decade and return samples from the Martian surface, something no country has ever accomplished. If successful, Tianwen-3 would represent one of the most complex robotic spacecraft missions ever attempted, and could position China as a leader in planetary sample return technology. The commercial side of the space industry continues evolving rapidly. Reports emerged this week that SpaceX has been exploring the possibility of future public listings on the NASDAQ exchange. While the company has long remained privately held, discussions around a potential listing highlights how enormous the company's valuation and its influence within the global space and geopolitical economy have become. Simultaneously, the next generation of commercial space stations continue to take shape. The Starlab commercial space station has already fully booked its available commercial research payload before the station even launches. Companies developing manufacturing technologies in microgravity are securing access years in advance, suggesting a strong demand for orbital research and production once the International Space Station eventually retires. International competition in human spaceflight is also intensifying. China has now revealed its likely landing region for its first crewed lunar mission. The targeted landing site lies within the Reim-Bode region of the Moon, an area featuring volcanic terrain and scientifically interesting geology. China aims to land astronauts on the lunar surface before 2030, setting up a parallel human lunar exploration program alongside NASA's Artemis effort. Finally, scientists are continuing to study the long-term effects of humanity's first planetary defense experiment. After NASA intentionally impacted the asteroid Dimorphos with the DART spacecraft in 2022, something we covered on this channel, new analysis suggests that the debris from the collision may have created a stream of rocky fragments that could remain in the solar system for thousands of years. While the experiment successfully demonstrated that humanity can alter the orbit of an asteroid, it also revealed how complex the physics of planetary defense can really be. And finally, after nearly 6 months without a launch attempt, activity at Starbase has accelerated rapidly as SpaceX prepares for Flight 12, the first launch of the version 3 Starship architecture. Booster 19 recently rolled out to the launch site, and it was lifted by the newly upgraded Mechazilla Tower at Pad 2 for the first time. Beneath the booster sits a new generation of engines, known as Raptor 3, representing a major redesign compared to the previous Raptor 2 engines. The engine layout itself shows a different philosophy, with a simplified configuration designed to improve reliability as Starship moves closer to operational service. The launch pad infrastructure has also been heavily modified based on lessons from previous Starship flights. One of the most important upgrades is the introduction of 2 booster quick disconnect interfaces on the launch mount instead of a single connection used previously. This allows propellant to be loaded significantly faster. During recent tests, liquid oxygen and methane was transferred in the booster in roughly 23 minutes, compared with about 39 minutes during earlier operations. That's almost twice as fast. Faster fueling reduces the amount of time the rocket sits on the pad with cryogenic propellant in its tanks, minimizing boil-off losses and improving operational efficiency dramatically. Recent tests focused on verifying the new launch infrastructure and engine systems as well. Engineers performed propellant loading tests, flow checks, and what appears to be blowdown tests, where gases are pushed through the engine plumbing to confirm that valves and connections are functioning correctly. Later testing may also include a spin prime procedure, where turbopumps are spun up using inert gas to verify startup performance without igniting the engines. Following the test, SpaceX deployed a drone equipped with a spotlight to inspect the booster and launch mount hardware, likely checking the new fueling interfaces and structural components after cryogenic operations. All of these steps are preparing the system for the first launch of Starship version 3, a major milestone as SpaceX transitions from experimental prototype towards a vehicle architecture designed for long-term operational missions. Now onto launches this week. This week also saw a busy launch schedule around the world. On March 10th, SpaceX launched a Falcon 9 rocket from Cape Canaveral, carrying the EchoStar 25 communication satellite to geostationary transfer orbit. March 12th was particularly active. Firefly Aerospace returned to flight with its Alpha rocket after last year's dramatic failure. The mission carried no payload and served as a test flight, but the launch did successfully demonstrate that the vehicle has returned to operational status. China also conducted 2 launches on that same day. A Long March 8A rocket placed 9 satellites into orbit for the SatNet communication constellation, a network often described as China's answer to Starlink. Later, a Long March 2D rocket launched a pair of satellites officially described as Earth observation spacecraft, though their exact mission has not been publicly confirmed. The week closed with 2 additional Falcon 9 launches, expanding SpaceX's Starlink constellation. On March 13th, a Falcon 9 launched from Vandenberg Space Force Base, carrying 25 Starlink satellites, followed on March 14th by another Falcon 9 launch from Cape Canaveral, carrying 29 additional satellites. With those launches now in play, the Starlink constellation sits well over 6,000 active satellites in orbit, making it by far the largest satellite network ever. Taken together, this week highlights how rapidly the global space industry is evolving. NASA is preparing to return astronauts to the moon while still solving major challenges within the Artemis architecture. SpaceX is pushing Starship towards a new generation of vehicles designed for full reusability. China is expanding its ambitions from lunar exploration to Mars sample return, and commercial companies are already investing in the infrastructure that could replace the International Space Station. Spaceflight today is no longer defined by a single program or a single nation. It's an entire ecosystem, and it's developing in parallel. The next few years may determine which of these systems ultimately reshape how humanity operates in space. I'll see you in the next episode of Spaceflight News.